freshly excised rabbit heart is placed in nutrient solution. The ascending aorta is secured to an inflow cannula through which nutrient solution may flow under a pressure similar to the normal diastolic aortic pressure. The tip of the inflow cannula lies just outside the aortic valve so that perfusion is directed into the coronary vessels. The injection of defibrinated blood into the inflow system outlines the coronary arterial bed, illustrating the perfusion pathway. The heart is prepared for recording. A catheter lies in the left ventricle for the recording of left intraventricular pressure. Stimulating electrodes are placed on the left atrium. A bipolar recording electrode placed on the aorta and the ventricle provides an electrogram representing both atrial and ventricular excitation. The heart is immersed in the nutrient solution for the remainder of the demonstration, except when photographed during drug responses. The electrogram and ventricular pressure recorded on magnetic tape are played into a storage oscilloscope. Norepinephrine injected into the spontaneously beating heart induces tachycardia, a positive chronotropic effect, and an increase in contractile force, a positive inotropic effect. At a slow sweep speed, the progressive change in intraventricular pressure is shown. Norepinephrine is seen to exert a positive chronotropic and a positive inotropic effect. The progressive response to norepinephrine is repeated on a magnified time base. Every second or third beat is allowed to trigger the oscilloscope sweep. Note the increase in the rate of change of pressure as the interval between beats decreases. After recovery, acetylcholine injected into the inflow cannula in the spontaneously beating heart causes a profound bradycardia. Block of atrioventricular conduction is apparent. The recorded response shows the initial electrical and mechanical asystole. During early recovery, a burst of electrical stimuli applied to the atrium results in a sustained atrial tachysystole, possibly atrial fibrillation. The stimulation was applied at that point. On a faster time base, the atrial and the ventricular rhythms are compared. The ratio of atrial to ventricular impulses illustrates a high degree of atrioventricular block. Within a few moments, the atrial arrhythmia spontaneously reverted to a 1-to-1 rhythm. At this point, reversion occurred. The acetylcholine effect is almost terminated. Now the heart is stimulated electrically in order to separate the effects of acetylcholine on AV conduction from those on spontaneous rate. The oscilloscope sweep is triggered by the stimulus artifact, shown in this diagram as the large deflection which just precedes the atrial excitation. Under these conditions of constant atrial drive, drug effects on atrioventricular conduction time can be observed. Acetylcholine is injected into the driven heart. The progressive effects of acetylcholine on atrioventricular conduction are shown just prior to complete AV block. In contrast to the striking block of AV conduction, atrial conduction was not affected.